this is a position graph. So S of t, S of position. So we're asked to graph the velocity. So if I'm going from position to velocity, I'm going down a level. So I got to take the derivative. But I don't have an equation to take the derivative of. I got to take the derivative of a graph. So how do we take derivatives of graphs? If you look at the slope, right? So you're going to have just a bunch of like flat lines. The slope here, I went like up 2 over 1, right? The slope there is 2. So what you do, that means the velocity is 2 during this section. So you put a little horizontal line there. And then we do put an open circle because if I asked you what's the derivative at that corner, you would tell me it doesn't exist, right? Hopefully you would tell me it doesn't exist. And then we just look at like section by section. So this next section, the slope of this is 0. So the derivative of this is 0, which means my velocity is 0 over that little segment. And the same with the next piece. So if I look at this third section, like from 2 to 3, I'm going down 4 over 1, which means my slope is -4. So I have a little horizontal line segment of -4. You just get like these steps. So what's the slope of this segment? 0. So I have this here at 0. And this is -2. And you can put closed brackets or closed dots at the end, or you can just like not put a dot. But you do need open circles in the middle because that represents that you can't take the derivative at those corners. Is that alright for 4? What else can I do on here? Were there other ones? Okay. I don't know why this just happened. A second. Okay, so this is the derivative. This is velocity. This is a velocity graph. So above the axis means positive velocity, we're moving forward. Below the axis, negative velocity, we're moving backwards. So like we're moving forwards here, backwards down here, and forwards here. Or you can think about it like right and left or up and down. It's all kind of the same concept. So when does it reverse direction? Would be at 2 because we switched from moving forward to moving backwards. And at like 7 point, good God, just put it on a number. 7 point whatever, because we're going from backwards to forwards. So t equals 2 and t equals 7.8. Thank you. When is the particle moving at a constant speed? So, like in this segment here from 0 to 1, is my velocity increasing, decreasing, or staying the same? Increasing, right? Because we're going up. Decreasing, well, what about right here? Increasing, decreasing, or staying the same? Staying the same. So that's your constant speed when it's horizontal. And then decreasing, increasing, decreasing. So between 3 and 4. What is the particle's maximum speed? So remember, speed is the absolute value of velocity. So speed doesn't have a direction, it just tells you like how fast. So what's the velocity right here is 2. Right here is 3. I'm sorry, what's the speed right here is 2. This here is 3, but what's the speed right here? It's 4. So it's -4 velocity, but your speed is 4. So the maximum speed happens. So what is the body's maximum speed? It'd be 4. What's the label on that? Meters per second. And then what time intervals is the body speeding up? So remember, speeding up means moving away from the x-axis on a velocity graph. So 0 to 1 because we're going away. 2 to 3 because we're going away. We're not speeding up here because it's constant. 4 to 5 because we're going away, and then 7.8 to 9 because we're going away. How's that, Trey?
Yeah, I think they just worded it different. Like they were like, when does the body reverse direction? So it's like, it just confused.
What else? What else? Yeah. Is there a time when the particle is at rest? Justify your answer. So this is a differentiable function. If it's differentiable, we also know it's continuous. So if you think about, if you're moving backwards here and then forwards here, didn't I have to at some point stop and change directions? So then I'm moving forward, I'm moving forward, I'm moving forward, I'm moving forward, I'm moving forward. I might have stopped somewhere in here. Like, it could be true that at 3 the velocity is 0. I don't know. It could be true at like 5.5 the velocity is 0. I don't know any of these, but I know that if the velocity switched from being negative to being positive, it was negative at one point, and now it's positive. I can't get from going this way to going this way without that brief moment of like turning around. So yes, since B of t changes from negative to positive. Does that make sense? They might have used like the intermediate value theorem on the answers to justify it. So remember the intermediate value theorem, it says that like if I'm 6'6" today and I was 5'8" at one point, then at some point I was 6 foot tall, somewhere in the middle. So if the velocity is negative 3 here, it's 2 here, at some point it had to hit every number in the middle of those and zeros in the middle of those. What else? What else? Okay. Let's do let's look at 4-3 notes, and then I'll give you time to work on that. Not like as long as class, but we got enough. We get out at 34. Alright, so rates of change is still the same idea, it's just not like a particle moving. It's other things changing. The amount of water in a pool, the number of pebbles that you're pouring sand into a thing. There's all sorts of things that come up with things that are increasing or decreasing. So to know if something is increasing or decreasing, you check the derivative. So if the derivative is positive, that means that whatever it is increasing. If the derivative is negative, that means that whatever it is decreasing. So did they put like the height is increasing if height prime is positive? Is that like what they put in the answers? Okay.
They did like better.
Okay, yeah. But like height prime, that's a weird thing to say.
I know.
So if you had a smiley face prime, that's literally it says in there. Okay, I like that. So the height is increasing if the derivative of height is positive. So we would say like height prime is positive, or height prime is greater than 0, or dh dt, if you wanted to call height h and then time, so you could look at it. I don't know if we're point. That's like the next lesson. I'm not sure. I think that's what we're like trying to get to. So velocity is decreasing if. So I could write velocity prime, but what else could I write? What is velocity prime? It's acceleration, isn't it? So I could put velocity prime is positive, or I could say acceleration is positive. And you can use positive or greater than 0. Like they're the same, you can write either one you want. Oh, yeah. I'm so excited about acceleration. Velocity negative. Velocity prime negative, or acceleration. Mr. Bruss, is that the guy that? Did you guys watch the video of him like skydiving? That's kind of cool. If IQ prime is positive, and then smiles.
It said smiley.
After?
The smiley face.
Like, what do I call that? The smiley face is decreasing.
Yes.
If smiley face
Yeah.
prime is less than 0. Fair enough. Should we review how to do the derivative with our calculator? Because I know even if you watch the video, they do it. They use the T84s. Should I review how to do that on your calculator? So grab your 89. Is there someone that knows how to do it in their calculator well enough that I could borrow theirs for a moment? Nerd. Yeah, nerds are cool. Is that the problem? Is that the one we like they're asking? Okay. So this is the one with the notes, 5 sine of x. Okay. Are you sure? I thought it was like E and cos or something.
Oh well, it is actually.
This is like one of the problems.
No, that's the nose, but it's 5 2. It's 5 to the side of x, not 5 times it.
Oh, okay. So hit F2, no, F3 for calculus. Differentiate. They said it's 5 to the sine of x. So 5 to the sine of x. And then you're going to tell the calculator comma x. And that's just telling the calculator what variable we're working with. You know, it's like dx, like dy dx. You think about like, there's your dx right there. And then you could do that, and it would just tell you the derivative. What?
You have an extra parenthesis at the end,
So that would give you the derivative. But you could also do the derivative at a point, which I think is where they're going on this one. So the derivative will be 5 to the sine of x. X, and then you put the vertical bar, which is like right next to the 7.
Put the extra parenthesis. You have
Double
close
parenthesis
to
after
the
sine of x.
You did it right though. You have the parenthesis after the
Oh, because you put a parenthesis after the.
There's 3 opens and 3 closed.
No,
Yeah, I'm good,
it's
right?
right. You added one after the root or the caret.
Oh, that's right. Because you pick
I don't need that one,
No.
but I like it. Damn
Yes.
it.
Yes.
So let me do it.
You're good.
So, and then what number they want me to plug in? 3? Oh, I should probably type the 3 before. And so that is not helpful to me. But so I'm going to switch this to, I'm going to go mode, scroll down, do switch to exact approximate. Matthew, I'm sorry if you want to
No,
put this back.
no, that's where I was going.
Okay. So then approximate, remember you gotta hit enter again to save it. And then you can just hit it again. So it's freaking -2 and you told me ln of 5 times 5.
Yeah, that's rounded. It's actually like
Is it? Does that help you? Is that a good enough refresher? For putting them in the calculator? Questions? No? Yes? Maybe.
Oh, that's
Thank you. Okay. So then we get this. So part of this is just like, again, working with this stuff over here, the units, and then estimating slope, which we've actually done before. So if f of x is the bunny population after x years, so you might add like, but f prime of x, so if f of x is bunnies, and we're working with the time of the unit that we're working in is years. If f of x is bunnies, what's the derivative of bunnies? Bunnies per year. So f prime of x of x would be bunnies per year. That someone's alarm. Did you forget that it was a BRT day? So f prime of x would be bunnies per year. Or you could say like the rate of change in bunnies. So those two things are saying the same thing. How fast is the bunny population changing? If f prime in this situation were positive, are we gaining or losing bunnies? Gaining. If f prime of x is negative, sadly losing bunnies. If f of x is the rate at which it increases, so now they're telling me f of x is the rate, so it already is bunnies per year. So they're starting us here. They're saying this is your original equation. So we're already in bunnies per year. And if I take the derivative of that, what's the label now? It's bunnies per year squared. So they're just starting us on this level and saying now take a level down. So if we're starting at the derivative level, we're at the second derivative level. So this would be bunnies per year squared. So f of x here is what you would typically think of as the second derivative level. And this would be the rate of change of the rate of change of bunnies. So it's basically, you can think about it like the acceleration. So the bunnies, we might be getting more of them or less of them. Are we getting more of them at a faster rate? Like is the rate that the bunnies are growing also increasing? Or is the rate that the bunnies are growing decreasing? And then rate of change from the table is not too bad. It's basically just like a slope formula. So if I ask you for p prime of 15, 15 is right in the middle there of 10 and 20, so I would do y2 minus y1 over x2 minus x1 with these 2 points. So I go 150 minus 120 over 20 minus 10. Plus 10. That'd be 30 over 10, so that would be 3. What would the label be on that one? We're at the velocity level, the derivative level, and our units are people in years, so that would be people per year. Is that okay for that one? What's up? Oh, not like a calculus question, just like curious with the people that whatever, yeah, I don't know. P prime of 20. So what I would do here, so I think there's 2 things that they would accept. There might actually be 3 or 4. But in my opinion, the best thing that you can do is find the slope between these 2. That which we just did, right? So that slope is 3 people per year. And then the slope between these 2. So I'm looking for like 10, 20, and 30. I'm looking for this. So I'm saying find this slope and then this slope, and we're going to average them together. That's what I think is the most accurate. So if I find this slope, it would be 200 minus 150 over 30 minus 20. So this would be 5 people per year. So in my estimation, the best I could do is say, well, when I was on the way to 20, the slope was 3. When I got past 20, now my slope was 5. So So I would say it's 4. So that will not always be the same. It will in this one. You get 80 over 20. That's 4. That's 4. So it will not always be the same, but they will always accept that answer. So another thing you can do, if you're not cool enough to do my method, you could go the 2 points on either side of the 20 and find the slope between those. And that would be the same. And in this one, it comes out the same, but it won't always. Is that okay on that type? Is that it? On the problems, you can skip number 5 and 10.
It's terrible. I already halfway through it, and I was like, this is really hard. 5.
Yeah, I feel like there's a way to do it. I just don't know what the way.
I'm looking at it, and it makes more sense.
I can see it really easily, but then
Please excuse the interruption. Lunch is based off your 5th hour class. If you have beat lunch, you will need to return to 5th hour for attendance purposes.
So 5 and 10 are both things that we will talk about like, in depth later. I'm not sure why we're like just gonna. I don't want to spend 10 minutes on it now if we're going to spend an hour on it later in the year. We will get to those, but I would not worry about 5 and 10 right now. So finish that up. Have the notes for 4.4 done for Monday. Keep going.